Okay. Um, okay. And I think we're gonna wait. So while we're waiting for other people, there should be more people, I think. I would like to tell a few things. 1 second, I will share my screen. Uh, Can you guys see the screen?
Yes.
Okay, perfect. And the screen, what they see in the screen would be nice to know.
It's just the first slide. It says penetration testing,
Okay,
beginner,
perfect.
networking.
Okay, okay. And can you see me? I'm not sure.
Yeah,
Okay.
I can see you.
This is kind of strange. Okay, maybe later I'm gonna look at the, because this is the first time I do recording on the Zoom meeting, so that's why I'm kind of confused. Okay, then we're gonna start. So the first one, I would like to thank you everyone for joining this meeting. This course, and so I'm doing this course because I think this I want to bring something back to the community, and I want people to be more exposed to hacking tricks, and maybe um, um, it also should help. This course should also help with uh, passing OCP test, offensive security penetration certification. And so there's some information gonna cross with OCP. There's some information gonna cross with other courses that you can find online. So the information is not mine. You can find absolutely everything online on Google, on YouTube, on Udemy, on any other classes. So it's not. I don't own this information. And so about myself, I'm currently working as sorry, I'm a little bit. I have sore throat. I currently work as penetration tester for a company called Pre-Tenets, and we do web application penetration testing. We do internal, external. We do Wi-Fi. Yeah, all kind of stuff like Active Directory, cloud. Previously, before switching to penetration testing, I worked as a software developer for several years, and I've never been to a tech school. I've learned everything on my own through internet, and I hope this class will help you to gain some knowledge that I will share. Also, I would like to mention that there's no limits. You don't have to limit yourself. And if someone, like some people tell like, oh, you have to have specific mind to be a penetration tester. You have to have like specific, I don't know, skills. Yes, skills, yes, you kind of gain them, right? But you don't have to be like people are not born to as a penetration testers. People become them, right? So keep it in mind and never compare yourself to others. Always try to achieve your own goals and look at yourself. And I was told many times that I have no tech college education, and like I have no background in tech, and I'm not that kind of gender or I don't know anything, all kind of stuff. And but it nothing stopped me, and I think I think everyone should do the same. Yeah, so let's start. So this course is for beginners. So yeah, I assume you have no knowledge in pen testing at all. And our first meeting, we're gonna dedicate to networking. Why? Because I think networking is one of the most thank you thank you for the message, one of the most like a foundational basics that you should know before jumping into pen testing. And so that's why I'm kind of I was like, I have to I have to put it there for sure. Anyway, let me switch. So with first one, I would like to mention about what is network, right? Network is a connection of devices on the between each other. So this is how we get a computer a network. So we can divide for this specific course. I'm gonna talk about LAN and WAN, right? Like a local network and like wild networks. That so the local one that you have like on your homework, maybe at your school and your organization, it could be connected between each other between with different devices like switches and but for the WAN, WAN, so this is like anything like other computers, right? So you connect through other computers with your router. And so this is like when you see LAN, that means local network, and V like WLAN, it means that Wi-Fi, right? So that you don't actually miss it. So what happens that when you go to the browser? So when you type actual, I honestly, I like this one. I found it online, and I like this JPEG, like this guy. You can actually go and like I put this link here. He creates all this kind of stuff. So I like how he put everything in a scheme for you, so that you can see how the data flows, how everything actually happens. So when you type, let's say, google.com, right, it goes to this DNS servers. The DNS servers usually have all the data in cache. If they don't have anything in cache, then they check it. If they have this google.com on the list, and then, yeah, we have it on the list. And then they give you the actual IP address. Why do we do that? We do that because we don't want like to memorize this IP address. It's pretty hard for actual regular humans. So we decided to have this DNS resolution, right? So now it goes back to ISP, and then what happens? Then we want to create a connection with the server, with this particular server, right? That's IP address that we were given. And so what happens that, one second. What happens that when we connect to the server, we actually create a three-way handshake. What is that? We're gonna talk about this a little bit later, but you have to like visualize in your mind, this is actually happening before we go to the server, right? Three-way handshake. So the client usually, what happens, like the clients say, hey, server, do you actually exist? Like, hey, hello. And server says, yes, I can see you, I exist. And it sends the package back to the client. and then client says, okay, let's connect then. And after that, the actual connection starts, right? So before we go, before we connect, it happens during like few milliseconds and you don't even notice that, but you have to keep in mind this. So then this is how we get HTTP requests or HTTPS, right? And the server might respond with different numbers. So one is information message, just like usually we don't actually, because I work in web applications, so you probably, some of you guys already work there. With this, you know that we don't see one much, so we see 200 like a success. We see 300 like when we redirect, right? We see 400 errors like for 4 and 500. So this is the 500, actually this one 500 server error is the most important, like the most valuable error that a penetration tester could get, because we strive for that, right? We want the server to make an error. So this is why we are talking about what kind of messages the server could get. Anyway, no matter what kind of errors we get several files back. It could be HTML, XML, CSS, like let's say there's JavaScript, right? And then it sends us back all those files, and the files actually get so the files actually get parsed by our browser, whatever browser you're using, Google Chrome, I don't know, anything. And then the browser knows how to actually show it to you on your browser. So that's the magic. We're gonna go a little bit. Oh my God, it's already 8:15, so I'm hoping that we're gonna finish everything. So we're gonna go right now a little bit deeper. So I don't know if you guys seen this OSI model. So it's well known between penetration testers, like IT people, especially network guys. They use it. Why? Because they usually use it to describe what happened on which level, on which layer happened the error, right? Like it's a physical layer 1 or layer 2, right? So, for example, so here, actually, if you want to memorize it, you can use this phrase. Please do not throw sausage pizza away. So use this first P, D, right? Like P physical, D data, and etc. So for the physical one, what we have anything that connects actual like physical world, like physical cables, right? How the data travel through the cables. Most of them, like probably for home, you're gonna have like Cat6 or Cat8 cable. The bigger the number, the more copper and the cleaner the signal. So Cat8 is the most fastest one. But probably at home you're currently using Cat6. So so also hubs. So hubs, we don't use hubs right now because what happened, like hubs would actually do flooding, right? They would send the information. What is flooding? They send the information to everyone, and they don't care where they send, like to so that would overwhelm the network. So now instead we use repeaters, so they actually don't flood. They know a little bit. They're much smarter than hubs, so they know where to send it. So the second layer is we have data, and the sorry, the first one we send the bit, right? We bits through the wires, right? For the second one, we send frames, and so in this case, anything that has MAC address gonna be on this. Anything that's using MAC address gonna be on this second aware data, right? So for example, switches, they use MAC addresses, right? Like here, you can see that the switches. Right after that, third layer, we have a network, and the network, usually third layers, we send packets. So this layer using IP addresses, right? So for example, routers between each other, they talk us with IP addresses. So we send the packet through this network layer. This is the fourth layer. We have a segment. We send segments, right? And usually it's about the connection, like what kind of what we transmit. We transmit TCP and UDP packages, right? This one. Then we go to the session. So anything like the session where create communication channels called sessions between devices, right? So it usually anything connect like anything about security, right? Session management, Apple Talk, right? So it's all on this layer happens. And the last one, oh no, this is not the last one. The sixth one is presentation. So what kind of files are we sending, right? We want to make sure that the right files get in the right application. And the last one, but not least, we have the application. So the application is like actually like, what is that? Is it PuTTY? Is it Safari? You know, or what kind of application we're using, right? So what happens that when we send the packet, we start from when we send the data, we start from layer 7, it goes down, and then the server receives, let's say, no server or another client, right? They receive the data. They go from here to up, right? So they go through the physical, through the wires, they get data, then network, and all this kind of where the packed together. When also the troubleshooting, you usually start troubleshooting with from layer 1. For example, if you have no internet, right, you make sure that is like let's say some application is not working, like you can get some websites working, right? We want to make sure that your physical layers actually connected to the internet. You have the internet, for example, and etc., etc. That's how usually professionals work. The next one. Then we have there's another model, TCP/IP. What's the difference? There's almost no difference. It's kind of all the same. They were developed at the same time, OSI model and TCP/IP. So OSI model is more theoretical. So this is like, it's, you know, more detailed. You want to actually see what's going on with application and how actually everything works, right? But TCP/IP is more practical model. So they have only few layers: application layer, transport layer, network, and network access layer. So these two combined here, and these three combined to application layer. So you should know about that. When you work with professionals like network people, and anyone who works in IT, if they say layer 1, so you have to know that it's physical, right? So, for example, or layer 2, you have to know this is any devices that work on MAC addresses. All right, a network where if they say no, layer 3, that means that anything connected like routers or anything, all kind of other devices that work with IP addresses. Moving on. So we have to talk about encapsulation. What is that? So it's basically we put the data like this one, right? Application where all this kind of stuff, all this data, we put it in like a package, and then we put it in another capsule that is layer 4, and layer 3 covers it with the whole thing with another package, like with another capsule. So this becomes data, and this one header, and then we add MAC, right, or for level 2, and this becomes data, and this one header. So this is how encapsulation works. So what is on the layer 2? So we're gonna go a little bit deeper how everything looks like. So what is the MAC address? So MAC address is actually media access control. So it's a number that's given to every physical hardware device on the internet. It could be your computer, it could be a router, it could be, I don't know, gaming device, whatever you can playing with. It could be anything. So by looking at the number, you can actually get the first 3. You can actually get the organization that made this device. For example, you can just search on Google, like you can go like this one, right? Vendor, this Wireshark tools, look up. You can put the MAC address and search find out what kind of what vendor made this device. For example, is it Apple? Is it Cisco? What is that, right? So just by actually the number one, you can actually find out if it is that virtual machine. So yeah, this MAC address, this should be unique for each device. Absolutely. Can we change it? Yes, we can change it. I will show you it later. I mean, like spoof it, not actually change it. But I'm gonna show it later on other core class, next class. Then so yeah, that's it. So the layer 3. So layer 3, it's network, internet protocol, right? So we have IP addresses. What is an IP address? So that IP address is 32 bits. And usually for understanding the network, we also need to understand the subnet mask, right? So for example, here we're saying so the network portion here is actually where my device sitting. And here's the device number, right? By which one it could be changed in here. For example, if you go to my network, it could be my Windows machine could be on 192.168.111, and then my Mac could be on 192.168.112, and etc. Right? So we have, because of this subnet mask, because of this, we can see that the subnet mask, the first 3 is 255.255.255, which means that which means this is the mask. It's actually show us how big the the network that we are on, right? So we have also 1 second. So in this one, when you see this a slash, and like let's say 16 or 30 or I don't know 24, this one CIDR. So CIDR, it helps us to understand again about the network, how big the network is, how many IPs addresses we have. For example, this one on the top, it has 24. Why do I know? How do I know it? Because I see the subnet mask, right? So it should be 24. So this is the class C, right? Where you see 25, 25, 25. This is the class C. The class C usually have CIDR 24, which means that we have 254 hosts on the network. So here we have to also mention that we have private IP addresses and public IP addresses. The private one you actually have on your network, on your home, at your companies that you work for. So nobody can see that from the global internet. And the public one, when you actually go to the server and you want to post something, like it could be an application, it could be, I don't know, just anything on the any kind of device on the internet, you can post it online and give it to public IP addresses. For this one, usually typical, like if you see this 10.0.0, 172.16, 192.168, 127.0, those are like actual private IP addresses. You will see them a lot when we're gonna work on actual machines, on hacking. And so these guys, when you see these numbers, like any kind of other numbers, right? We went here. So if anything not looking like this, any other numbers, that's probably public. If it's if that IP address accessible online from from any point of the planet, that's public. So how do we? There's few classes of the public, right? For example, class A. That's a huge, like the biggest, like the most biggest organization have it. So they go. There's only yeah, so there's only 128 networks like that, and we have like millions of IP addresses there available on each network. Then we have class B. So usually it's like regular normal organization, like they have this size. So if you see that, actually the subnet mask gonna show you. So the first subnet mask shows how big the internet. You remember that I showed you before, right? If we go here, so the subnet. How did they know that it was class C? Because we have we have 3.255. The same way here, we have 3.255/24. So that means it's actually class C. Each class C network, it's probably that what you have at your home, that you're gonna have like on virtual machines and stuff like that. So we have only 256 IP addresses per network. We don't use reserved and we don't use multicast, right? So this one, yeah, I said with medium class, large size networks, right? So the class B, class C, that, yeah, actually with so many 2 million networks, right? and class D and class E expand here. So the class E not available for general use, they're just for research purposes, and class D is for multicasting, right? So it's like for TV cables and stuff like that. Okay, so the problem is it was all good until people figured out that we actually get more and more devices, and the networks like have too many IP addresses. Like, for example, if you need only two like free machines on the network, why would you pay for the whole thing, right? Why would you get like I don't know, bigger than you need? Or for example, you need a little bit more than 256. So that's why we've done classless addressing. So what does it mean? So the seeder, that remember I was showing the seeder here, right? So the seeder, this one is showing 32. So what does it mean? Does it mean that we have only one here? We have only one single IP address, but it's not gonna communicate with with anyone because we need more than one. We need actually 4 IP addresses to host one computer, so that it would be able to communicate with other computers, right? Like because we have like 3 IP addresses that gonna be like, one is gonna be set for network, another one for gateway, and then the last one gonna be for broadcasting, and gonna have only one IP address on that small network right here, one usable address. Okay, so I think that's it. So basically, you don't need to memorize this, but you have to know this exists, and you have to know how to use it. Well, what I do, I just go here. You guys probably don't see it. I go here to calculator.net. I don't know, here, calculator.net, and it's actually I put the IP address and the seeder, and it actually shows me how big is the network. So I don't have to keep in mind everything and calculate in my head. It's kind of complicated, but if you want to, you can actually learn it by yourself. Yeah, because we got more and more devices. Well, what happens that we don't have, like, with this dot decimal notation, right, numeric notation, we have only 3 billion addresses. But the problem is, like, we get more devices every year. Like, internet is growing, and so people decided, oh, how about we just create IPv6, which is much more bigger and have more, like, way more IP addresses. But the problem is that we don't usually use this IPv6 right now. It just happens that it's turned on automatically by default. And it's an amazing way for the hackers to get in, because usually IPv6 is not, there's not much research about that, and hackers use if they see IPv6 is on, they know that they can use it. So what is recommended for any companies, for home network, for anything, if you don't use IPv6, please turn it off. If you would like to learn more about subnetting, I do really recommend this online class on Udemy that I love it. I took a bunch of classes with this guy, but he's a genius. Like, the way he explained about IP address and subnetting. It was, it was so easy. But again, you don't have to. But you just need to understand that we have IPv4, IPv6. How does it look like, right? And you have to, if you see them, some strange, like usually some strange IP addresses with strange CEDAR notation, you have to know that, oh, I actually can use, Google to figure out how big is the network, right? And you need to understand the classes. Also, you need to know that like it's a subnet mask, because we're gonna use it where just to show that the subnet mask, how big is network, right? What is next? What next? Okay, where for? To on wave 4, we connect with actual devices with ports. So there's more than 65,000 ports. That's a huge number. Like if you're gonna, when we're gonna do penetration testing, I'm gonna show you how to find what ports are open, and when you try to knock off, like not knock off, I mean like when you try to recon all the 65,000 with nmap, is gonna take some time, so it's a lot. But there's about 1,000 well-known ports, and so the well-known ports, which are used by system processes that provide widely used type of network services. For example, HTTP, right? I don't know, SSH, anything else. So we're gonna go deeper into that. So there's also dynamic or private ports. Those ports are reserved, and they cannot be registered with IANA. So this is organization actually managing the list, the protocols, I guess. Because and also we have registered ports, right, with this one. So why do we need them? We need them because they're used for specific application. So like when, for example, you use one, like let's say when you Zoom, there's gonna be a port gonna be open somewhere here in between these numbers. If you would like to see all the ports, you can go to these links that I provided here. But we're not going to go through all of them. Okay. So what happens? There's TCP and UDP. So the ports could be on TCP or UDP, right? So what's the difference between TCP and UDP? TCP is reliable. It's make sure that when the package comes in order. For example, when we send a message, like text message, or when we send a file, request a file, right? The TCP actually, or share the header. So we show the destination port and source port, right? Then we have the sequence number. What is sequence number? It's used to sort the received package. What happened that we have how we all connected. We all connected through other computers, right? And the package can come from all different kind of ways. It's not just going one linear through the same steps and the same computers, right? The same links. It does not. It usually, I don't know, it happens due to internet. It comes from all different, waves. ways. And so what happened? The TCP actually, it checks if we received all the packages and if we actually put them in specific order that they should be, right? So this is why we have acknowledge number and sequence number. So we also have the flags. So we have data here, right? So the flags is like SYN-ACK. So remember we were talking about SYN-ACK on the first, absolutely the first one. Where's the first one? Here, that one. That's what we're going to talk about right now. A little bit more deeper. So what happened that when this is the flags, right? So when we send a request to server, we saying let's connect. So like, are you there? SYN, we send SYN, and then the server send back SYN-ACK is saying yes, I'm actually here and I can open. Let's have the connection. Then we send back ACK, and like again, right? So we have the connection open, but when the server can be open all the time, so we need to finish it. So we need to finish the connection. This is how the connection should be finished. So we're saying, okay, we established the connection, we want to finish it, let's finish it. And both the server sent FINAC, and then yes, we close the connection with that. So you need to know this, what does it mean? Because later we're gonna work with that. What next? UDP is another way. It's kind of like TCP, but it's not reliable. So if you see that we have on the source port, destination port, and we have data here compared to this one, right? We don't have sequence numbers. This one is much bigger. You see what TCP header, like way bigger, twice bigger. And UDP is much smaller. The packets smaller, right? We don't need a three-way handshake. We don't need to make sure that everything in order. So what is usually happens, like where do we use it? We use it in Zoom meetings, right? When the streaming, like, you know, if some packets are lost, we don't really care about that. But when it comes to text messages, for example, right, or browsing on the internet, we want to make sure that all the files came in. So that's why we use TCP. And here we use UDP for Zoom meetings. So usually what happens, like, for example, for Zoom, when we start the connection, it starts with TCP. And then as soon as the connection started, it goes to UDP port. What kind of ports we have? Well-known ports here. Again, you don't have to memorize it, but it's better to know all of them because you're gonna use them on penetration testing. You have to get very familiar with all the ports. So what does that mean and when we use it on the network? So for example, FTP is well known, so file transfer protocol, like PuTTY, for example, right? SSH, secure shell, we're gonna work a lot with SSH. And what else? Telnet for we're gonna see about some, you know, people don't like, companies don't use Telnet, but yeah, we're gonna see a little bit on our own machines. SMTP, so this one for the mail transfer. So then the DNS, you can see the DNS actually used for both on both UDP and TCP ports, right? Just notice that both like some of the ports could be used on both TCP and UDP, and some of the ports only on TCP or only on UDP. When we're gonna do Nmap, when you're gonna do recon and penetration testing, I'm gonna actually show you that to go through the ports, UDP ports is gonna take way longer than TCP ports for specific reason. I'm gonna explain why it happens. Right? HTTP, like how you go to internet. For long like decades, we used HTTP, and it would send a clear text. And this is how a lot of famous hackers got famous, because we did not actually secure anything, all these messages, and you could see everything clearly on the internet. And later, not so long time ago, we got HTTPS, which is on port 443, which actually secures the message that we send, the packet that we send with TLS, right? SSL and TLS is kind of the same, but TLS like a newer version of SSL. So but this one should be that's what we're using now. This one Gmail, right? Mail, sending kind of for free, right? SMB, you're gonna see RDP, it's remote desktop protocol. We're gonna use like when you connect remotely to a computer and you see the whole desktop, that's the port they're using. SMB is actually used a lot in Active Directory, and it has a lot of vulnerabilities, and yeah, we help companies to make sure that it's secure. So yeah, just go through this. You can actually go here on Wikipedia and see yourself that the whole list of the ports. Again, you don't have to memorize it, but it's better to like when we're gonna go through the machines, we're gonna do actually hacking session. You're gonna get used to that. If you would like to learn a little bit more, so here's the book I really recommend this book, because I have it. I have several more, but I think this one is the most accurate and the most like compact one. And also you can do CCNA course online on Udemy or YouTube. So there's a bunch of them. So CCNA basically goes a little bit deeper into the network, and it explains the same way, layers by layers, right? Or side layers that we talked about before. There were the layers. Yeah, this one. It's gonna go through that one, and yeah, it's gonna teach you how to manage the firewalls and routers. That's kind of it. So I think that's it for tonight. It's like was less than an hour. So do you guys have any questions? Oh, for the homework, I wanted to ask you to figure out how to log in into your router and turn off IPv6 if you're not using it. And I'm pretty sure you're not using it. So yeah, that's your homework. Yeah. Is there any questions? So what if you have any question, you have like 5 minutes, maybe, yeah, before we finish it. I just wanted to make sure that, I wanted to tell that I'm gonna post this video online, and also I'm gonna post this PDF for you. And uh, of and for us, like, I have one, how to say that, um like an advice, I don't know, like, right? So if you would like to become a penetration tester and actually pass OCP class, OCP exam, um, please do as many notes as you can. You do a lot of screenshots, put all those nice notes all together, and whatever. Even like, yes, I'm gonna give you this PDF, but maybe you already know something, right? So you don't need the whole thing. Maybe, like, when you put something into your notes, and then it's way easier. What's best when you actually gonna memorize it better, like, and another one is way easier to search because the information is not separately laying somewhere on different PDFs, and but it's in one source, for example, right? That's kind of